Parq construction project located in the central business district of Bangkok, right at the intersection of Ramaphore Road and Rashida Pisek, and next to the important and well-known locations such as Queen Sirikit National Convention Center with access to the MRT. Altogether, the park is estimated to have a total net worth of 20,000 million baht. The center theme of this project is Work Well and Lie Well, and it will be the first construction project to achieve the global standard credentials of LEED and WELL. The park will have a total floor space of over 320,000 meters squared, divided into hotel, office and rental spaces spanning over an area of 24 rai, with a received right to release the land of the Crown Property Bureau for a period of 30 years with an additional extension of another 30 years. The park can be divided into 4 main zones, with the first zone being the parking lot building, containing a total of 2 floors with sufficient parking space to serve all expected customers. The second zone is a retail area with a large variety of shops, restaurants and services such as a fitness center. The third floor of the zone is composed of many large open spaces, making it difficult for the design of post-tension slabs. An open-for-rent office low zone spans the 4th to the 10th floor with a large open space in the middle, separating the building into 2 different sides. The high office zone starts at the 11th floor and reaches up to the 16th. This zone is also open for rent, with additional leisure features for employees to enjoy and relax at the site of a public park. Post-tension floors are constructed by first setting up scaffolding. The scaffolding used here is a special type of scaffolding which is easily assembled. First, a pole is erected as an initial support. Then, floor panels of 1.2 meter width and 2 meter length are plugged into the fastening latch on both ends of the pole. The end of the pole is then used to push the end of the wooden panel up and adjust the scaffolding level to be 3 meters tall. Once assembly of the wooden panels is finished, the scaffolding will be strong enough to bear the weight of the poured concrete. Reinforcement is then laid out with a spacing of 30 centimeters and the tendon ducts are put in place. Ends of the tendons are covered in tape to prevent piercing of the ducts once inserted. Post-tension bar chairs are used to elevate the tendon ducts according to the design profile. Each of the bar chairs are color-coded according to the height to aid workers. PVC pipes are then inserted as a pathway for grouting. Once tendon profiling is completed, concrete is ready to be poured, starting from the edge of the structure, whilst being careful to obtain even leveling of the concrete surface. Once the concrete starts to harden, the surface is burnished to smoothen and flatten the surface and get rid of any surface water. After the concrete has completely hardened, the wooden side frames are removed in preparation for post-tensioning. Usually, this step occurs once the concrete has reached the age of 3 days. Before jacking, the tendons are sprayed with paint in order to easily identify the pre-stress distance. Each tendon is checked individually one by one, according to the designed amount of required pre-stress. Jaws are used to prevent the tendon from slipping. Grout is then poured into the tendon ducts to form a bond between the duct and the tendon wires. Once the grout has set, some of the wood paneling is removed to be used in the next floor segment. These poles transfer the load down the tiers. Installation of windows on the exterior of the building is performed by using a small crane. This spider-type crane carries the glass window panels from the bottom floors up to the steel frames fixed to the floor slabs. This smaller crane is more efficient than using the larger tower crane for these kind of small fixtures. In the engine room, a large oil tank made of concrete is constructed to serve as storage for oil leaks, allowing for easier removal of oil. This room requires sound insulation from the large machine engines, and therefore, the walls are covered in dense bricks and special sound insulating panels are used on the ceiling. The air conditioning ducts used here are made of pre-insulated duct panels instead of the traditional zinc ducts. This new material provides high efficiency in heat and moisture insulation. This new material satisfies the standard of green building by being sustainable, anti-corrosion, antibacterial, lightweight, and easy to install. Steel sheets are placed before pouring of the concrete to support hanging pipes. After removal of the wooden framework, the pipes are attached to supporting steel sheets. These embedded steel sheet hooks help to carry the weight of the hanging pipes. Precast wall panels are used on the ground to cover the imperfect surface and joints of the diaphragm wall. Drain passages are placed to allow water drainage of water flowing through the diaphragm walls. After construction of piles is finished, the ground is removed to perform pile capping. The top of the diaphragm wall is casted as a cap beam. When removing the ground surface, a wheel is used around the circumference of the diaphragm wall. The kingposts are hammered into the ground according to the design depth and position. Struts are installed to support the wheels, transferring the load towards the kingposts. Steel platforms are laid on the struts to allow for excavators to run on the platforms to remove soil for the next layer of struts and wheels. Finally, scaffolding is set up to prepare for casting of the parking lot floor. Once the floor has hardened, the struts are removed.